Hello everyone, thanks for joining this presentation about the variety and variability in heavy civil engineering. My name is Fischer and I am a PhD student at Professor Fortner's chair at the Technical University of Munich. And first of all, I want to thank Iris Tommerlein for the very nice collaboration and the excellent contribution. So we first start with the introduction. I will tell you the purpose of this paper. Then I will present the related work, the 7 sources of variability and their tools to address it. And in the end, we look at the conclusions. We start with the Industry 4.0 expression. This is first mentioned in the German high-tech strategy plans for 2020, and it is characterized by the implementation of a digitalized production. A key lesson from lean production is, however, that a pure adaptation of technologies does not optimize a process. So process flows must be understood in detail to eliminate waste, and sources of variability must be identified to, in the end, improve or try to improve the system. And this is what the paper is focused on. The sector we are looking at is the pile production, so the special civil engineering with its pile drilling machines or equipment. This equipment you can see here in these pictures. This is a rotary drilling rig, and this is used for making large diameter board piles. And as you can consider this, there exist only few documents describe this process and its variabilities. So by the help of interviews with experts and also by comparing the results with common literature, we tried to answer these 3 questions. So first, what are the key differences between the civil engineering, the heavy civil engineering, the foundation civil engineering, and the multi-story building construction in terms of application of lean principles? Then which variabilities influence the Kelly drilling production as a typical and widely used drilling method? And how may these be addressed by Industry 4.0 technologies? When we look at multi-story construction, there the crane operations are important when trying to design work standards to reduce variabilities. So they are the pacemakers. They are largely responsible for material flow and are used by many stakeholders on site. On the other side, we have the earthworks, which are more focusing on the interaction between the equipment, not so much the sharing of the equipment. And in contrast, we have the foundation pile production, which is isolated and limited as an one-piece flow line dependent on the single machine, so the rotary drilling rig, because the process is very complex. And but in this study, we look at the variety and variability, and we also want to look at the assumption that the system is paced by equipment, and we want to ask if this is the question. So in doing so, we try to capture the product as well as the process variability and to distinguish between them to easily derive recommendations. Here's just an overview about the process itself. showed as a value stream map. We see the drilling, the reinforcing, and the concreting as main steps. And then we come to the sources. We revealed the 7 sources. We have here, for example, the contractual requirements. They are very important in the design phase, as early involvement of the experts can minimize the product variability, as they may aim to standardize the length, the inclination, or the diameter of the piles. We can also see the operator skill, which is, for example, very important to increase performances. The expert says 20% more when there is a good operator on the equipment. These are just examples, and we quickly come to the results concerning the Industry 4.0 tools, where we compared these 4 tools: the digital models like BIM or GIS models, the IoT as connecting all entities on the construction site. Then we have the artificial intelligence as a data analysis, and in the end we consider the simulation as a proven tool for testing complex systems in advance, and but not widely used in practice. And overall, the use of the tools can help make systems more predictable by tracking, visualizing, or even monitoring. So we revealed 7 sources in the end and recommend different technologies. We compared them, and we come to the conclusion that not all variability will be removable, but incrementally the production system will evolve to new future states, each with new systems, design challenges to be overcome. And the comparison of the application of lean principles, however, shows that even equipment-intensive processes can be improved by focusing the human factors, like the expert knowledge in the design phase or the operator skills, and there are lots more. And in the end, the transferred collaborative partnerships involve at an early stage can improve the pile design towards production aspects, and our next steps will be the implementation of lean principles and standardization in this sector. We want to standardize the workflows and finally capture the variability in simulation studies. So thank you very much for your attention.